Hello and welcome to this lecture. In this lecture, we are going to talk about sets. So set is one of the most important data structures to know while you want to make your application more robust and more friendly. So set in the Python is a data structure equivalent to the set in a mathematics. So if you have ever known about the set, or if you have done every numerical calculation related to the set in a mathematics, then this should be pretty easy for you. So it may consist of various element and the order of the element in the set is undefined. So just remember that in the case of a dictionary, the order of the element is always defined, but the case of the set, the order of the element is always undefined. You can add and delete element of a set. You can iterate the element of a set like you normally do in the case of a list, and you can also perform standard operation on the set like union, intersection, difference. Beside that, you can also check if an element is belong to the set or not. So if you have ever used array, something like array in the case of C# or Java, where the element are stored as an order list, the order of the element in the set is undefined. Moreover, the set element are usually not stored in order of appearance in the set. This allows this feature, that is the unordered set features, allows checking if an element belongs to the set faster than just going through all of the element in the set like we normally do in the case of a list. So checking the element in the set becomes faster because it is unordered. So any immutable data type can be element of a set, a number, a string, or a tuple, or a mutable changeable data type. So any immutable data type can be the element of a set like a number, string, or a tuple, but a mutable or a changeable data type cannot be the element of a set. In particular, that is list cannot be the element of a set, but tuple can be, because a tuple is a immutable data type and a list is a mutable data type. And must remember thing about the set is another set cannot be the element of a set like we normally have in the case of a list. When I say li, then one list, or inside this list you can have a nested element 1 2 3, and inside this you can have another list even here like 5 and 6. So this won't be the case of a set. That means another set cannot be the element of the set. Thus the requirement of immutability follows from the way how do computer represents set in the memory. So let's see how this set can be defined in the Python. So we normally define it using these braces like we normally do in the case of a dictionary. So let me say define a list for me, and we'll just have this a. So if I just say type of this a, and you could see the a would be dict. But if I just say a, and let me just define the dictionary again, and let me say 1, and next would be 3, and let me say 5, and if I just hit press or hit enter here, and let me say the type of this a one more time, then you could see the type is now changed to set. So this is a set, but if it is in the value or it is in the pair like a key value pair, that means it is a dictionary. But if you normally give or pass all the elements like here in this curly braces, it is normally changed to the set. So set is basically an element that is unordered. So when I just print this a over here, it is 1 3 5 over here. So let me first create the set, another set using this set method, and in this you can pass any set that is element with this set. Let me say queued, and if I just hit a here, then you could see the QU is it. So if you see here, it is unordered. So I was just saying before that the set is unordered. That means it is just independent of how you just create this set. So if you see here, Q is basically over here, R is in this position, but in the case of printing this set, you could see R goes in this index. So basically it is independent of any index. So let me see one more time, that is if it is T here, so T belongs at this last position when you create this set. So set is independent of any position of the way that you created it. So we can say the order of elements in the set is undefined. Moreover, the set element are usually not stored in the order of the appearance in this set. So one important thing to know about the set is it is unordered, unlike any list which is ordered. Basically, if I just say a, let me just create the list, it is not going to change. So if you just see, anytime you print this down, then it is going to stay in the order that is 1 to 3 over here. So now let me just create the Python script, and over here let me just save this down first, and let me say set.py and save it on this lecture folder. So let me first create the variable which would be obviously our set, and let me say 1 to 3, and let me go down and create another variable over here which would be another set, and let me say 3, 2 and 3 and 1, and let me just close our set with these closing curly braces. Let me just print this down, a is equal b. So what would you think the output would be? So let me save this down first and run it over here. So let me just close this down first and save this down again and run it here. Then it is saying just true. So that means if I just create here, that is same b over here, that is 3, 2, 3 and 1, and if I just say b over here, it is 1 to 3. So the repetition is just converted to the single digit or a single data type in the case of this set. So just remember that. So if you have a and if you have b, then that means you have something that is a true over here, which is this set.py has. So basically a has 1 to 3, b also has 1 to 3, that means a is equal b. So you could see true is over here, which is our output. So it is true because the a and b are equal set. And if I just create the set like this, let me say hello, and you could see that is, let me just close this down, and it is saying the list which contains like this, which has a 2L over here, but it is just converted to 1L. And if you could see here, that is, it is unordered list. That means you can just indexed or you can just references of the element quickly than any ordered list or any ordered array. So let's talk now about the operation that can be done with the element. So first operation can be a len function, which basically gives the length of the element of this set. So furthermore, we'll just create another variable in order to check the primes, and let me say primes first, and let me just give prime number over here. Let me say 2, 3, 5, it should be 5, and next one would be 7, and the last one would be 11. So these are the bunch of all primes. Now first of all, we have to just print this num. So in order to do that, we'll just say num in primes, and if you just print this down, which is our num, and you could see all of these primes, which is 2, 3, 5, 7, and basically this is primes which is created in this dictionary. So if you could see here, we have just iterated over this prime. So that means you can just loop around this set. So primes, or basically this is our prime, which is obviously the set, is the iterable data type. So we have just justified here, that is the set can be iterated using this loop, which is in this case the for loop. So let me just define another here the program. So let me just go back to this console, and let me just print it one more time, and now let me just create the another dictionary. So here I'll just say 1, 2, 3, and you know how to create the dictionary by using this curly braces. So let me just print this down now, that is print me 1 in a. So we have something that is in keyword to check if the element is in this dictionary or not. So if I just print this down, then you could see true and true. That means 1 is in this dictionary A, 4 is not in this dictionary A. So what if I just print the same statement over here, but with the some change in it? So let me just say A, and 4 in, let me say in A. So if I just print this down, it should be true false, because 1 is in A, obviously the one element is in A, but 4 is not in A. That means it should be false over here. So we can do this operation using this in keyword, or basically it is same as saying we have a iteration over here. That means you can iterate and modify any element in this set. So next is to just add the element to the set. So in order to add the element, we make use of this add method. So I'll just say add me 4 over here, and let me just print this down one more time, and a is that is basically 4 is added to the a. So now if I just print this down one more time, let me just copy this down and print it over here. You could see true and true because now a has 4 elements added to it using this add method. So in order to add the element, you can make use of this add method, and basically it can add any of the data types. So let me just say, let me add, that would be, let me say string. So let me just add this one. So if I just say a here, then string is added but at the last position. So usually the addition would be at the last position, so just remember that. And now it's time to see how we can just pop out or remove the element. So we have something that is the remove and discard method. So in order to just show you that, let me just create one more dictionary over here. Let me say 1 2 3 4, and you could see the dictionary just popping out here, which is 1 2 3 4. So what if I make use of something like a discard method, and let me say discard the element like 2. So 2 should be discarded, and if I just say here a, then that means 2 is discarded or removed from this set a. And we have another method, that is remove method. So when I just call this remove method, and I'll just say 1 should be removed, then if I just print a, then there is a 3 and 4. So if you wonder, we have the 2 method over here, that is remove and discard, doing the same thing, but these are the 2 method, that is to remove the element from the set and discard. And this remove method behavior varies only in the one case, and if it is to be deleted the item which is not in the set. So we'll just check the behavior difference between this discard and remove. So in order to see that, so first of all, let me say remove, and this remove, let me just remove all of this element from this list basically, and I'll just say one more remove, and I'll just say remove me, that is next element, which would be 4. And if I just say a is basically now empty set. So now let's call this discard method first. So if I just say discard me the element, and let me just hit enter here. So this is obviously an error when we just didn't put any argument over here in this discard. So let me just say remove me 4 from this set. So when I just say 4, that means it is not going to crash, so nothing is going to happen if you make use of this discard. That means discard does nothing if you want to just remove any element from your set. But in the case of this remove, let's see what this remove does. Usually it should throw you a key error. So let me just say remove me element, and that should be the same element, that would be 4. And if I just press enter, you could see key error and saying the 4 is basically not present over here in this set. So basically if you just remove the element from the list using this remove method, then you could crash your app. So it is always an best practice to use the discard instead of remove while removing the element from your set. So you can always change your set to the list using this list function. So if you want to just, let me just make another list first. So let me say 1 2 3, and this is our new set. And if I want to just change this set to the list, then we make use of this list method. Then if I just say a, then that means this set which is containing 1 and 2 3 is converted to this list containing the same item 1 2 and 3, and it can be done using this list method. So just a quick review over here, set can be created using these curly braces. It can be also created using the set method, and we have something that is add method in order to add the element to the list, and discard and remove method in order to remove the element from the list. Its behaviors remains the same until you have elements to be removed from the set. But if you don't have any element to be removed from the set, normally remove will just throw you a key error. But in the case of a discard, you just continue, it won't do anything, it will just say nothing over here, no error whatsoever using this discard. So it is always the best practice to use the discard instead of using this remove statement in order to remove the element from your set. So next thing what we learned was using this list method in order to convert your set set to the list. So now it's time to check some of the operations that can be performed on the set. So these are the operations that can be performed with this set. So basically, if you have ever used the set in the mathematics, it is same like here, and basically you could see the union operation is basically returning a set which is a union of set A and B. So if you could see the union, that means if you have a element 1 to 3, B element 2 and 3, then you could get the union which is basically 1 2 3 4, which is using this union method. So let me just take one example from here. You could do multiple operations using this method, which is update method. Using intersection, you could have this difference method, asymmetric difference method, but I'll just make use of this union in order to show you how this union just return a set which is basically a union of set A and B. You can similarly use all of this method in order to do multiple operation, and the description is over here. You can just collect this documentation from the resource section. So let me just take example, just implementation of this union. So let me make a variable that is set variable A, and it will contain 1 3 and 4, and let me say B variable, which is obviously the next set, and it will contain 2 and 3 and 5. Now it's time to just make a union of this set. So let me say A union B, and let me just say B over here. Then you could say union over here. That means you have the all of these element union, or basically you have a addition over here. You have 1 and 1 over here, 2 and 2, 3 from this set A, 4 from this set A, 5 from your set B. So it contains all the element that you have in this set A and B, and no repetition is allowed. So that means the 3 is counted only once in this union set. So this will be the wrap for this lecture, and you can just make use of multiple method in order to do multiple operations, and you could get the documentation in order to just check out this multiple method, and you can just take insight of it, how the union and other operations like difference, asymmetric operations are performed using this set. So see you in the next one.